So guys, today we are going to learn how to add, subtract radicals. Also, we need to know some information as we are dealing with these sets or the radicals. We are going to combine like terms, but you have to know that like terms must have the same degree and the same degree coefficient and then are the same radical. So anything that's under the radical is called a radicand. Okay, so if we look at this example here, we realize that the radicand here is 2 and the radicand here is 2x. So because of that, this is not a like term. And when we look at here, the radicand is 3x and here is 3x. And then we look the coefficient is of degree 3 and here is of degree 3. So because of that, this is a like term. And here when we look at the radicand is 2 and here is 2, and we look at the coefficient, this is a constant and this is a constant, therefore this is a like term. Here we have been given this that we have to simplify. So first of all, we have to be able to identify our like terms and then we can go ahead and combine the like terms. So here is x here. If you want to make the work easier, you can put 1 over there, nothing wrong with that. And here too you can put 1 outside here. There's nothing wrong with that. If that make it easier for you, can go ahead and do that. And here we realize that this is 3 and this is 3 and the degree is 1 here, or is a linear, and here the degree is 1. So indeed these two are like terms, and here we have the radicand. Here is 3 and here 3. The coefficients are constant and they are also a like term, so we are going to combine that. When we are combining, we just look at the coefficient. That tells us this is 1 and this is 4. So this makes 5. So it's going to be 5x root 3. And we come to the next one. Here is 1. Here is 2. So they also make 3 and it's positive. So it's plus 3 root 3. At this point, we cannot combine them because they are not of the same class. Therefore, this is our final. So our next work example, we have x here, we have x here. We look at the coefficient. This is of degree 1. This is a constant, so the underlying term. This is a cube here, but I believe we can able to break the cube down, so we have to work on that. So we know that x squared, when we are looking for the non-negative, we get x here. So we have to break this 1 into that. So we will write our 5. So we can rewrite this as x squared times x. It's still the same cube, but we know that square root of x squared become x, so that will come outside here. So that will come outside, leaving this x behind, and then we have to write the rest of it. Now we have to combine like terms. These two are of like terms. If you want, you can put 1 here. They have the same degree coefficient and they have the same radical. So we can combine them, and it's 2 plus 1. That make it 3. So here we got 3x root x here. Here we will write our 5 root x, and that simplify the whole expression. Yeah, so we have a square root of 72 minus 3 root 2 to simplify. Here, most of the time, we have to look at the radicand to see if we can break the 72 with respect to the 2 to see if it's going to help us. Or what have to come into your mind is a perfect squares. You have to think of your perfect squares, which is a 4, 9, 16, 25, 36, 49. But here, this gives us a clue because they are not of the same. So we have to do a little breakdown. So let's break down this to this. We know that one number times 2 will give us a 72 is 36. So here, break this one down as 36 times 2, and then you rewrite. 36 is a perfect square. We are looking at non-negative, so we are just looking at the positive side of it. Square root of 36 is 6, and it comes outside, leaving 2 behind. Here we realize that they are of constant, the same radical, so we can go ahead and subtract. So we subtract 6 minus 3 root of 2, and that gives us 3 root 2 as an answer. Okay, so we have root of 20 and root of 45 minus root of 50. Realize that these numbers, none of them is like terms, so we have to break them down. When we're breaking them down into perfect squares, so when we think of perfect squares, it's gotta be looking at 4, 9, 16, 64. All these things are perfect squares. I believe we can break this one down with respect to 4. 4 can go here. Here can be break down as 4 times 5. And 45, 9 can go in there. Now we see that one of the number that's not perfect square is 5. So that have to give us a clue that we have to break it down into 5 to see, get some kind of a like term. Here we can go with 9 times 5. Now everything is going with 5. So here, a number times 5 will give us this. We realize that 10 is not a perfect, so that we are going to break this one down to this 25 here. So 25 times 2 is that. Now, square root of 4 is 2. So it come out as a coefficient, leaving the 5 behind, plus square root of 9 is 3, come out, leaving the 5 behind. Square root of 25 is 5, come out, leaving the 2 behind. Here you realize that this is of the same radical, they have the same degree, they are constant and constant, so they can be combined. This one have a radical of 2, so it's not a like term to this. So we combine these 2 here, we get 5, and then root minus 5 root 2. We cannot combine this, so we leave this as a simplified form, and we are done. Okay, we have been given this expression here. They want us to simplify. That means we have to break it down into some kind of perfect squares and see how we can combine like terms. Normally, if there is a simplified form in it, it gives us a clue. That means we have to break this bigger numbers down with respect to the 3 and see what will come out of it. So here we will rewrite, give to that plus here 75 divided by 3 is 25, so we know that is 25 times 3, and that's really good because 25 is a perfect square. The 48, we also break that one down with respect to 3, so 48 divided by 3, realize that it's 16, so 16 times 3 will give us 48. Now we are making a headway. We will rewrite this, and square root of 25 is 5. So that come out. Square root of 16 is 4. Come out as such. Now we have the same radical and then the constants. So they are like terms. So what we have to do, we are bringing all of them together. We are just using the coefficients. So we got -2 plus 5 plus 4, and then all have the same radical. Here we combine this, they are positive, we get 9. The positive is bigger, so 9 we take away 2, and that gives us 7. So we got 7 root 3 as a simplified form. So let's look at this last example here. We're going to simplify. Here we see a lot of variables. We realize that none of them is a like term, but I believe we can able to break it down and we will see what will come out of it. One thing that we have to know from the beginning, we said that this x squared here, some kind of a perfect square, because square root of x squared when we are looking at the non-negative, give us x. Let's break x to the power 5 into respect to x squared. So here we write our 3, and this can be broken down as square and then squared and then x minus 4. So the same thing, then x here plus 2x here, x squared and x. But we know that square root of x squared is x here. So it's going to be times x with this, and then another will come out. So there's another one, leaving only this one behind. Same thing, this comes 1 and 2, so that leaving this behind. Got 2x here, this 1 will come out there, leaving this x behind. Here x times x, and then 3 will become 3x squared, square root of x minus 4 x squared, leaving the x behind, minus 2x squared, square root of x here. So here we realize that the radicals are all the same and the coefficients have the same degree. So we will combine like terms. We bring this and then this together. So this and this is 5 minus the 4x squared, and then they all have this radical x here, and that make it square root of x as a final answer. Okay, please subscribe, like it and share, and leave a comment, and I see you in the next video. Thank you for watching.